Good day, fellow students. Good day, family and friends. And good day, my people out there who are always watching my video, who are always giving comments for me to know that indeed they are following what we are teaching them out there. In the same manner, I will encourage you and I will say that if today is your first time you having or having into contact or getting into contact with this video, you make sure that you watch this video to the fullest because we are here to give you the best that you deserve. All right. So today too, let's see what I have for you and what mathematics has for us today. There are some students, certain student came out with a certain question that I guess I am here to explain it a bit, and I guess sharing it out there too will help others to know how to solve the problem in an easy manner. Maybe today is your first time, or maybe you are encountering problem with exponential equations. So today I am here to give you a gist about exponential equation. Do not worry, just stay close and make sure that you stay with us here so that at the end of the day, we hope that you'll be blessed. Right, so let's see how to solve this question that we have here. So we have exponential equation, and the idea of exponential equation, have it in mind that we are going to employ what we call the rules and indices over here to solve a whole lot of problems over here. So using the idea of indices, I believe you are much abreast with indices. Don't worry if you are not abreast with that. In the course of me solving it with you, I'll make sure that you understand the concept one after the other. Now, do not forget to subscribe. You hit the notification bell so that always whenever we upload set videos, you will also be the first person to get in touch with us. Very good. So let's continue with the process. So let's see my question number one. I have 4 exponent x minus 2, which is equal to 1 out of 8 exponential x minus 1. So let me rewrite this one more so that you will understand what I'm trying to say. So we have um, an equation with which the power of the 4 here as a whole number is x minus 2, and this is a fraction. I get it. Now, this question, we have several ways in solving problems in mathematics. For instance, something like this, we have several ways. So let's see how to solve it in an easy manner. I get it. Right. Now, the first thing, let's take it easy. Let's take it cool. The first thing that I would say we should do is, if this is a whole number with an exponent, why didn't we convert this one into a whole number so that we will get a whole number and then an exponent? So how are you going to do that? Have it in mind that in one of the laws of indices, it states that if we have this 1 over a, okay, this can be expressed as a power negative 1. Are you following? Very good. So in the same manner, assuming I have this 1 over a power x, this can also be rewritten as a power negative x. What does it mean? It means that as soon as this base a moves upwards, a negative exponent multiplies the old exponent x. Are you following? That's what it means. You see, over here, the power here is x. So as soon as the a here moves upwards, a negative exponent comes and multiplies that. I get me. So a negative exponent comes and multiply that. So over here, the power was 1. A negative exponent 1 came and multiplied the old exponent, which is 1. That is why we are getting, you see, negative 1 times 1 gives us what? Negative 1. And here too, negative 1 times x, we are going to get what? Negative what? X. That's why we had a power negative x. The same man, if we have 1 over a, let's say x plus 1. Are you getting me? Here we are going to get what we said. As soon as the base a moves upwards, a negative um, power comes and multiply the old exponent. So here I'm going to get a negative power multiplying the old exponent, which is x plus 1. Are you getting me? So here, if we are to expand the powers, we are going to get what? Negative 1 times x is negative x, and negative 1 times positive 1 is what? Negative 1. So this is what we are going to get. Please, I believe you are following. Very good. Now the question is, I believe you get this. Have it in mind, I said you understand it, and I believe you are enjoying the lesson. Okay, so let's proceed with life. The same, and if I have this, okay, so I think I'll end it there. I told you that if I have this, let me say I have this 2 minus x. So rewriting this one to be in a whole number form. This is a fraction. So if I want to write this to be a whole number form, I can rewrite this one as a, that is a negative exponent will come and multiply the old one, which is 2 minus x. Okay, and this gives me, using the negative one to expand, I'm going to get negative 2 plus x, because negative 1 times negative x gives me what? Positive. So this is what I'm going to get. The same manner, let's come here. Okay, so this is the whole number for the fraction that's, and I believe we are getting that. So here mathematically can be rewritten as 4 exponent x minus 2, which is equal to, say, the whole number for this fraction gives us 8 power negative 1. The negative will come and multiply the old exponent, which is 2x minus 1. Please, I believe you are following the process. Very good. So let's continue with the next part of the question in terms of solving it. So here now, here is now a whole number. Here is now a whole number. But with that, let me complete the power over there so that it will become a stable that. So power. So here I am completing it. So I'm going to use the negative to expand it so that it will be what? Complete. So using that, I'm going to get what? Negative 2x, and negative times negative 1 gives me what? Positive 1. Now it is complete. Now it is what? Complete. Now here is now a whole number. Here too now is also a whole number. And I believe you are getting it. Very good. So now our next idea. So this was my first approach and my second approach. This idea simply means, you see, this implies this and it implies this. Now, when we get to this portion, we are going to employ another idea of indices. We state that anytime that we are solving equations, we should make sure that the basis tends to be the same. So equations involving whole numbers and fractions, sorry, whole numbers and exponents, we should make sure that the basis tends to be the same before we can do justice to the powers. So here, let's check something here. The base here is what? 4. And here the base here is what? 8. Are they the same? No. So I have to make sure that they tend to be the same. So let's come here. You see, 4 can be expressed as 2 power 2. Okay? 2 exponent 2. 2 exponent 2 is the same as 2 times 2. And this gives me what? 4. So it's the same as 2 power 2 over there. I believe you are following. Very good. In the same manner, it means if I have this 4 power x, this can be expressed as 2 multiplying what? X. I believe you are following. Very good. So here the power was 1. It means this is what I'm going to get. And mathematically, this gives me what? 2 power 2. I believe it is clear. And here that can be also be expressed as 2 power 2x. So when we have 4 power x plus 1, this can be expressed as 2 power 2 multiplying the old exponent, which is x plus 1. I believe you are following the concept. And this can also be written as expanding this to become stable. I'm getting 2x plus 2 as the exponent. I believe you are enjoying the lesson. So in the same manner, when I come here, this can be expressed as 2 power 2. So 2 power 2 gives us 4, multiplying the old exponent, which is x minus 2, which is equal to, so let's come to this place. So here now the base is what? 2 now. And here to have to make sure the base becomes the same as this. So let's move on with life. My next approach is, you see, this 8 here can be expressed as 2 power 3. You agree with that? Because 2 power 3 is can be simplified as 2 times 2 times 2. Are you getting that? And it gives me what? 2 times 2 is 4 times 2 is what? 8. So it gives me that. So this one also means that the 8 here has a power of what? 1, because it is a whole number. And this new exponent will come and multiply that one, when I'm going to get what? 2 power 3. And that's what it means. So listen, if I have 8 power x, it means 2 power 3 multiplying x, which gives me 2 power 3x. I believe you are getting the concept. Very good. So if I have 8 exponent x, let's say minus 1, this can be expressed as 2 power 3 multiplying x minus 1. Are you all right? So we are getting 2 power 3x minus 3, using this 3 to expand. That's what we are getting. So in the same manner, when we come here, this can be written as 2 power 3 multiplying the old exponent, which is negative 2x plus 1. I believe you are following. Very good. So now we continue with the solution to the question. So we are still solving it. So let me divide it into 2. Then after, we'll make sure that you understand the question. I believe you are picking up something now and you are enjoying the lesson. Very good. So let's continue with line. So here, is it over here? Now let's check something here. The bases are the same, right? The bases are the same. But before that, let's come here and let me make sure that the powers become stable by expanding it with a new one. So here the 2 will expand that, where I'm going to get what? 2x. So this 2 will multiply this, I'm going to get 2x. And this 2 here will multiply the negative 2. So I'm going to get what? Negative 4, which is equal to, now over here too, the base here is 2. The 3 will expand that. So I'm going to get negative 6x. Okay, so 3 times negative 2x gives me what? Negative 6x. And 3 by positive 1 gives me what? Positive 3. So here we are going to employ the idea of indices, the other idea of indices, which also state that when we are solving equations which involves bases and exponent, we should make sure that the bases are the same. Now that the bases are the same, what we are going to do, we are going to equate the powers. I guess that's what the rule of indices states. So if the bases are the same, this is the base here is 2, here to the base here is 2. They are the same. So I'm going to equate. Equating means I'm going to take the power here, which is 2x minus 4, then I will equate you to the power here, which is negative 6x plus 3. So here I'm now getting a linear equation. So getting a linear equation, solving for x, because the question says that we should solve for x. So I'll group line terms. So grouping line terms, I want to group all the terms with x variables attached to it. So this one has x variable. I'll write my 2x here. And this one has x variable, so I will transpose it, or I will move it to the other side. Now moving this whole thing to the other side, have it in mind that it is negative, so when it comes here, it becomes what? Positive x, which is equal to, I write down my constant, which is 3 here. It is positive, so I will still maintain it as it is. Then negative 4 will come to this side. It is negative, so when it crosses, it becomes what? Positive. Right, so we continue with the next procedure. Now I have 2x plus 6x. When we add, we are going to get what? 8x, which is equal to, this gives us what? 7. So I'll divide here by 8, here 2 by 8. So the 8 cancels out, and I'm going to get what? X, which is equal to 7 out of 8. So this then becomes my answer for x. I believe you had a concept well. There is another way in going about an alternative way, but because of time, let's stick to this. And I believe you are getting the process and you are getting the concept, and everything is moving on smoothly. Very good. So that is how to go about it. Now, let's now dive into question number 2. So I believe now that you understand how to solve question number 1, you can easily solve question number 2, right? So let's dive into that. So with respect to my question number 2, I have a fraction which is 1 over 9 power x, which is equal to 1 over 27. Okay, so here the rule states that if the equation involves fractions, we should make sure that they tend to be what? Whole numbers. I get me. So this one also has a lot of ways in going about it, but I'll make sure that we use the easiest way. I get in, which is making sure that this one becomes a whole number and this also becomes a whole number. So as we said, when we have this, it is the same as a power negative 1. So when I have this, okay, it's the same as a power negative x. And I believe you remember this. Okay, so here can be rewritten as 9 power negative x, which is equal to, what is the power of the 27 here? It is 1, because it is a whole number. All right, so the power here becomes 27 power negative 1. Okay, yes. So the fraction 1 out of 27 becomes this. I believe we are clear with that. Very good. And over here too, 1 out of 9 power x becomes what this. So now we've turned them into what? Whole numbers. 9 is a whole number, 27 is a whole number. What are we going to do next? What we are going to do next is, now that they are in whole number like structure, then it means that our next approach is to make sure that the bases are the same. So what are we going to do? We are going to choose a common base for the 9 and then the 27 over there. Now have it in mind that 9 can be written as 3 power 2. I get it, mean? So now that we have 9 power negative s, it can be written as 3 power 2 multiplying the old exponent, which is this. Let me write my 2 words. So this is what we are going to get. So I have 3 power 2 multiplying that. All right. So in the same manner, when we dive into this part, which is 27, can be expressed as 3 power 3. Let's check something here. 3 power 3 gives us 3 times 3 times 3. 339 times 3, which is what? 27. I believe it is clear. Very good. So here, when we come to this side, we are going to get 3 power 3 multiplying the old one, because 3 power 3 gives us 27. So now that the bases are the same, what I'm going to do, let me expand the power here and the power there so that it becomes what? Stable. So I have 3 power negative 2x. Remember the 2 is expanding, which is equal to 3 is expanding. So 3 power negative 3. I believe you are following. Very good. So now let's come to the next part of, or the next section of the solution. I am now having something here like this. Okay. So over here, now we employ the idea of indices over here, which state that if we are solving two equations and then the equation involve bases and powers, you should make sure the bases are the same before we can equate the powers. So now that the bases are the same, what we are going to equate the powers. So here the base is 3, the base here is 3, so I'm going to equate the powers. So I will have negative 2x. I will equate it to the next power, which is negative what? 3. Are you following? Very good. So here I will divide through by negative 2, here 2 by negative 2, so that this will get rid of that. And the negative signs will cancel. So I'm getting x to be equal to 3 out of 2. And to make it stable, this becomes an improper fraction. So it tends to be a proper fraction. And I'll conclude that therefore my x is equal to 2 goes into 3, 1, leaving a remainder of what? 1 out of 2. So x becomes one whole number, 1 out of 2. So that becomes the solution for question number 2. I believe it is clear. Very good. So we are continuing with the next part of the procedure or the question, which is question number 3. Should I leave question number 3 for you? Or we should dive into it? So quickly, let's dive into question number 3. So question number 3, let me use my red pen, which is root of 3 power 2x minus 1, which is now equal to 1 out of 81. Okay, so this is also an equation which we have asserted, and the term under the radical sign has a power, right? So here too it's a fraction. So our first thing to do, please, let's make sure that if this is a whole number, I mean not a whole number, but I mean it is not a fraction, then we should make sure that this one tends not to be a fraction. I get me. We are going to rewrite this one of the form with which the fraction goes away. I get it. Very good. And I will still remind you that in one of the laws of indices, we say that if you have 1 out of a, it is the same as 1 power negative 1. Sorry, a power negative 1. Sorry. So here can be rewritten as 3 power 2x minus 1, which is equal to, this is the same as 81 power negative 1. I believe you are clear with that. Very good. Let me write this place well so that you will see what I have written here. So this one was 1 over 81. Are you okay with that? Very good. My 81, let me write it well. Okay. So now, though this is a whole number, yes, but it has a radical sign on it. So what we are going to get rid of the radical sign. Okay. So over here, there are two ways in going about it. I get it. Now remember this, but I want us to look at the easiest way. Okay, the easiest way. So remember this. If I have something like root of a, which is equal to m, and I want to make m the subject over here. If I want to make m the subject, or make sure that m stands on its own, what I do is I square here and I square here too. Okay, so that this cancels that. I get me, and I'm going to get a to be equal to m squared. I get that. So in the same manner, I'm going to employ the same ideology here. I believe it is you are clear with that. Very good. So I'm going to employ the same ideology over there, where I'm going to square here and I'm going to square here too, so that everything becomes nice, nice, nice. Right. So when I come here, so this one cancels that. Okay. Then over here, that's not cancel. All right. It does not cancel. Now have it in mind that here the power here is 1. So there is another rule in indices which state that, or which describes an exponent raised to another exponent, whereby when we have something like this, 2 power 2 or power 3, this is an exponent raised to another exponent. So here the exponent 3 will multiply that, which gives me 2 power 3 times 2 gives me what? 6. So here is the same as that. I get me. So over here the 2 multiplies this. Okay, it multiplies that, then it became this. I get in that. Very good. So in the same manner, when we come here, this will multiply this. I believe you are clear with that. Very good. So here, if I should rewrite it well, now the radical sign is gone. The radical sign is gone. So it is now left with 3 power 2x minus 1, which is equal to, then this will multiply that because it is exponent raised to another exponent. So 2 times negative 1 gives me, so I have 81 power negative 2. I believe we are clear with that. Very good. So now we are done getting rid of the radical sign. We are done getting rid of that. So let's continue with life. We are done getting rid of that. Now, the next part is, here the base is 3. Over here, the base is 81. So we should make sure that the bases are the same. How do we go by that? Let's check if we have a 3 power any number that will give us 81. Let's check it here. So we know that 3 power 1 is the same as 3. 3 power 2 gives us 9. 3 power 3 gives us what? 27. And we have 3 power 4 gives us 81. Are you following the concept? So you are getting this? I getting that. Because 3 by 3 gives us this, by that, by that. So here, when you come to this portion, I can rewrite this one as 3 power 2x minus 1, which is equal to, so 3 power, it was 3 power 4, which gives us 81. So 3 power 4 in a bracket negative 1, 2. I getting a bit. The new exponent will multiply the old one, because here the power here is 1 negative 2. All right. So here, let's continue with life. Now, if I should continue with the process, I now have 3. I want to make this one stable, so I have 3 power 2x minus 1, which is equal to 3 power 4 times negative 2, which gives me what? Negative 8. So we employ the idea of indices here, which state that if we are solving an equation involving two bases which are the same, what do? We equate the powers. So now the base here is 3, the base here 2 is what? 3. And I'm going to equate the powers. Very good. So let's continue with that. The power here is 2x minus 1, which is equal to, the power here is negative 8. So I'll group like this. So here I have only 2 with variable x attached to it. So I'll maintain that one. And this is a constant. So it goes here. The sign here is negative. So please take note of that, which is equal to negative 8. The 8 here is negative. Then this one comes here, it becomes positive 1. So I'm getting 2x, which is equal to, this gives me what? Negative 8 plus 1 gives me negative 7. Where to then find the challenge? Please take note. Negative 8 plus 1 is negative 7. So I'll divide here by 2, here 2 by 2. And 2 cancels out. Well, I'm going to get x be equal to negative 7 out of 2. And mathematically, let me conclude here that therefore, our x becomes the value of x. Okay, let me write my x for. Therefore, the value of x, 2 goes into 7 how many times? 3 times. I'm going to get negative 3 whole number, 1 out of 2. So we are getting the value of x to be negative 3 whole number, 1 out of 2, because we had negative 7 over 2, and writing this improper fraction in a mixed fractional form, we are going to get negative 3 whole number, 1 out of 2. Thank you very much, my fellow students, and thank you very much, my followers. I believe you really enjoyed the lesson. So I will encourage you that you make sure you subscribe to this channel and you share the video as well, so that your colleagues out there will also benefit. Likewise, you are benefiting now. I am your math teacher, Richard Oben, and I am here. I created this channel purposely to help students who are out there facing challenges in mathematics. Whichever the problem may be, please make sure you bring it in the comment section, then we will help you to solve your problem. Thank you very much, and may you have a wonderful day.